there. 5.1, introduction to decimals. Okay, decimals and fractions are very related because we can always write a fraction as a decimal by dividing. We can also write a decimal as a fraction. So you're going to see us do that a lot today because they're very related to each other. Well, this whole chapter actually. The first thing we need to know about decimals is place value. So I'm going to try to write this on sort of kind of like vertically, but when we do numbers, we talked about the left side of the decimal point. I'm not going to put them all, but we know we have hundreds, we have tens, and we have the ones places, right? All right, now what's after the ones place is the decimal place. When we have the decimal, when we talk about a number, we always say and. So let's say I have 123.4. I would say, and I'm going to go back into this in a minute, but I would say this number as 123 and 4/10. But so the decimal place, we think of it as the and. We say and when we see a decimal place. Okay, so here are the places after the decimal place. We have, after decimal, we have the tenths. We have the hundredths. We have the thousandths. We have the 10,000ths. We have the 100,000ths. I'm gonna do that in 2 lines, but I can't fit it. 100,000ths. And then we have the millionths. And then of course, more and more, but we're only going to talk about up to the millions. Hey, if you notice, I don't know, I call these the THS, the ths, because every single one after a decimal place has a THS at the end, like tenths, hundredths, thousandths. That's how you know where you are. If you see a THS, we're talking about after a decimal place. Means after the decimal. They mirror the other side, except for the once. So like tens and tenths. So tens doesn't have the TH, so that's on the left side of decimal place. And then tenths has a THS, that means it's on the right side of decimal place, etc. All right, so now, like I said, decimals and fractions sort of kind of go together because we can rewrite them back and forth between each other. So when you see the word tenths in fractions terms, that's 1/10. It's like 10 reciprocated, 1/10. When you see hundredths, that's 100, but reciprocated, 1/100. If you see thousands, that would be 1,000, but reciprocated, 1,000, 1/1000. 10,000ths. That'd be 1/10,000. And then 100 thousandths, thousand, I forgot my D, 100 thousandths, 1/100,000. And lastly, millionths, 1/1,000,000. So it's just reciprocal of the number it represents. So 10 tenths, 1/10, 100 hundredths. I think I just spelled hundreds wrong. Did I? Hundreds. Yes, I forgot my D, hundredths. 1/100, etc. Okay, so I'll go back to what I sort of kind of gave a little example early, reading numbers with decimals. How do you read it? How do you write it? I guess I should put reading and writing. And writing. Okay, so if I have like 21.324, okay, so I know we say 21.324, which is fine, but if I had to write it in words, it would be 21 and meaning the decimal place, right? And a decimal place, that's your decimal place. 300 24. Now, then you end it where what it is. It's 324 tenths, hundredths, thousandths. What is the last? This is tenths, hundredths, thousandths, ends in the thousands. So 21 and 324 thousandths. That's the last four. The last number ends in the thousands. All right, so let's look at another one. Let's do 34.6. Now, of course, we don't say it out loud as, 34, blah, blah, blah. We say 34.6, which is fine. But if we had to write it out in words, it would be 34 and 6. Now, 6 is in, that's my last number, right? 6 is in the tenths place, 6 tenths. I'll do one more. Let's do something like this, 0.0834. Okay, so we don't have a number, right? So we don't have to use the and because we don't have a whole number in front. It just starts in the decimals. So we're going to do 800. If I can write 100, hold on. 100. 34. Okay, now where does the last n? So we have tenths, hundreds, thousands, 10,000s. The 4 ends in the 10,000. So 10,000s. So you always look to see where your number ends. That's the number you put at the end, 10,000s. I know, I'll do one more. 8.71. Okay, so that would be 8, the whole number, and the decimal, 71, and then where's the one? Which place is the one in? This would be the tenths, this would be the hundredths. Hundredths. And that's how you write out a number that is a decimal. And I know paying online is a thing and everyone does it. I do it too a lot. But I don't know if you guys ever written out checks. I mean, it sounds weird, but you think everyone has written out check. But in today's world, sometimes people haven't written out checks. But check writing is the same thing, basically. So we talk about money. I think about check writing. Because if you have a check, right? And I don't know if you guys are real familiar with checks, but you have a check and you put who you're writing a check out for, right? And then underneath, it'll say something like dollars, right? So let's say I have a check. I'm writing out a check for $124.67. Okay. So I would write out in my hand, I hope I can fit it. 100. And over here would be the dollar amount. You do 124.67. This all makes sense? You guys ever seen this before? I mean, it sounds weird, but all right, 100 in today's world, I don't know. Okay, $124. And then, okay, I gotta make this line a little bigger. Sorry. I'll take my dollars out. You would write and then you do 67 over 100. Remember that?
You're
Right?
making me feel old, Miss Garrett.
Yeah. So 67 over 100 means 67 cents, but what did you just write? I know it's real small. It's 67 over 100. You just said it's 67 hundredths, right? Because in money, I mean, in math, this is the tenths and this is the hundredths. And we just learned that a hundredths, you can write it in a fraction form as 67 over 100. So when you write a check, you're also using your decimal form in a form of a fraction. I don't know if you guys ever realized that. All right, so that's even a segue to what I want to do next. So first, we have to be able to say and write the decimals correctly. And second, you use it all the time in real life if you're writing a check, even if in some way you're using it every day for a check. But now it also goes to our fractions. So even check writing goes to decimal to fractions. So cents is really over 100. So if you have like 52 cents, you really have 52 cents out of a dollar or out of 100, hundredths, times hundredths is a hundredths place. Very interesting, the connection. Okay, so now I want to take that segue and we are going to write decimals as fractions, so we can practice that. Now, just like a fraction, a decimal, so a fraction, we talked about fractions. Fractions represent a part over a whole, right? So if I say 5 out of 8, I have 5 parts out of 8. Well, decimals are the same thing. Decimals also represent a part of a whole. And I'm going to make like a little chart here talking about decimals and how to go from decimal we're gonna talk about the words, and then we're gonna talk about putting it right into like a fraction. Okay, so I'm gonna make a little chart. So we're gonna do a decimal. We're gonna do the words. And then we're gonna write it as a fraction. I'll hold up a minute while you write that out. Okay, so we'll start with something small, 0.9. Okay, in words, that is 9/10 because it's in the tenths place. The 9 ends in the tenths place. There's nothing after the 9. Which I need to talk about in a second too. How do I write that in a fraction form? It'd be 9 out of 10, 9/10. That's our part of our whole. So that's why a decimal also represents a part of a whole. All right, look at this one, 0.43. And by the way, when you deal with decimals and you don't have a whole number, usually you put a 0 in the front. It is not wrong to put 0.43 like that. You'll see me put a 0 in the front just to be clear that where the decimal place is. But the 0 doesn't really, I can't say matter. It really doesn't matter. But I always put a 0 in front of decimal place. All right, so this would be in words, 43. Now it ends, the 3, that last number ends in the hundreds, 43 hundredths. And that would be 43 out of 100. I look at 0.007. Oh, by the way, 43 should have a dash. Go back, put a dash, 40-3. Okay, 7. What places sevens in? It's tenths, hundred thousandths, 7 thousandths. That would be 7 over out of 1,000. And then I have one more, 0.03. So that would be 3. The 3 ends in the tenths, hundredths place, 3 hundredths. And that would be 3 over 100. Now, there's something maybe you never realized before, some kind of connection I always think about, but here's something, if it helps, awesome. If not, there's something I just think about. Okay, notice that the number of decimal places like the first one is 1 decimal place, the second one we talked about 0.43 is 2 decimal places, etc. Equals the number of zeros in the denominator. After the 0. I mean, after 0, after the 1, sorry. And I'll show you what I mean here. I'll like underline. See how we have 3 decimal places? See how we have 3 zeros? See how we have 2 decimal places? I have 2 zeros after the 1. If I have 1 decimal place, I have 1 0 after the 1. Just some kind of connection that I thought about as I wrote this down. Interesting, right? So let's say, let me pick a bigger decimal place or a smaller decimal, 0.0004. Okay, if I want to write that as a fraction, I count the decimal places. So I have 1, 2, 3, 4. That means I gotta have a 1 with 4 zeros. And that makes sense because this is the tenths, this is the hundredths, this is the thousandths, that is the 10,000th place. So maybe it's just a way to check yourself or something to think about. Just an observation I had. Hey, any questions so far? Because I'm going to make a new page. Oops.
I'm almost done writing down what you got by that star.
What's it again?
I'm almost done writing what you got.
Okay, yeah. I'll hold on. That's what, yeah, go ahead. That's why I'm holding up for a second before I start a new page. So this is like getting us ready. What we're going to do on the next page is we're going to write, I'm going to write down different decimals and we're going to write them as fractions.
All right, you can go to the next page.
Okay, perfect. Okay, so just a couple things, just like more like practice. So we're going to practice a little bit. Practice. Couple different skills. So, write the following as fractions. That's the directions. I'm going to give you 2 of them and you can practice, see how you do. Okay, so I'm just going to write them down, then I'm going to be quiet and you guys see if you can write them as fractions. 0.051, 0.1325. By the way, for right now, I just want you to write it, not simplify it. If it can be simplified, just let it stay. I just want you to write it. Okay, so try writing them as fractions. See how you do. Okay, I'm gonna write the answers down. Don't look unless you're ready. Hey, I have them down so you can look, see how you did. Now, of course, it's a fraction. So normally it would tell you to simplify the fraction. So the number 2 can be simplified, but we're just practicing how to write it as fractions right now. Good? Okay, so now write, we haven't done this yet. Write the following. I'm going to do 1 and show you how to do it. Write the following as a mixed number. So let me do 1 and then I'll give you a couple. You probably already know how to do it, but I want to make sure. So if I have 29.97, how do I write that as a mixed number? Well, 29 is my whole number. And then I make the 0.97 my fraction. So it'd be 97 over 100. That's what I mean by writing it as a mixed number. So 21 is your whole number. And then the part, the fraction, the part 0.97 is the part is over 100. So 97 over 100. Notice again, 2 decimal places, 2 zeros. Just as something you could, you know what it's really good for? Checking yourself. Like do it and then go back and go, okay, it should have 2 zeros. I have 2 zeros. Yeah. Okay, so try this one. 143.12. I'm gonna give you 2 of them. And then 3. So try those 2. Again, don't simplify, we're just practicing writing them, that's it. Okay, I wrote them down if you want to check. I just want to show you one more, because we didn't talk about negatives yet. What do you do if it's negative? So like negative 124.0009, something like that. It's the same thing. It's just instead of 124, it's negative 124. That's your whole. And then 9 over 1, 2, 3, 4, 1 and 4 zeros. 1, 2, 3, 4, 1 over 10,000. Can't speak. Negative 124 and 9 over 10,000. Now, that being said, you should be able to go backwards too. Like I could write, actually, let me write this, write the following as a decimal. If I write 124 over, oh, this is a good one, 10,000. How do you write that as a decimal? Okay, so we know there's no whole number, so 0 point. We know it's 124, but it has to be in a 10,000s place. Notice there's 4 zeros, right? 1, 2, 3, 4. So I know that I have to have 4 numbers. So it has to be 0, 1, 2, 4. Another way you can check yourself too, using the 0 thing, because it has to be a 10,000s place. This is a tenths, this is a hundreds, this is a thousands, that's a 10,000s place. Let's try this one. Negative 6 and 5 over 100. Okay, so we have a whole and we have our part. So negative 6, 5 has to be in the hundreds place, and 0, 5, because this is my tenths, this is my hundreds. How can I make sure I'm right? It had to be 2 decimal places. So it had to be 2 parts. So we should be able to go back and forth between doing decimals and fractions to decimals. All right, now we're going to look at comparing decimals. All right, so let me write this out real fast. To compare decimals, you compare each corresponding digit to see which one is, depending on what you're looking for, bigger or smaller, depending on the question. If it asks you for the bigger one, you look for the bigger one, smaller one, you look for a smaller one. So for instance, example, you'll see something like compare 28.253 and 28.263. So I'm going to compare one thing at a time. And when I mean compare, it means you're going to do, I should probably write that. Example, we're going to use less than, greater than, or equal to. That's what I mean by compare. So we're going to compare each decimal at each place in the number, not decimal, each number. So 2 and 2, they're equal. 8 and 8, they're equal. 2 and 2, they're equal. Okay, now I see a difference. Hold on. I see a 5 and I see a 6. So which one is, let's say I asked for the bigger one. Which one's the bigger one? This one's the bigger one. Because the first time the decimal place is bigger. So I'd write it something like this. 28.263 is bigger than 28.253. You compare one digit to one digit. All right, so we're going to practice some of these. So the directions are compare these decimals, use less than, greater than, or equal to. One, 26.208. And I'll leave a space in between 26.28. So I compare every part, every digit part. So same, not the same. So I'm gonna look, 0 and 8. 8 is bigger than 0, so that second one is the bigger number. So that means the first one is less than, the second one's greater than. Two, 0.12 and 0.026. We're going to compare each part. 0 is the same as 0. Oh, I already see the difference already. 1 is bigger than 0, right? So that means this has to be greater than. $142.339, 142.3390. This is where I got to talk about something I wanted to talk about before. Okay, so that's the same, 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 but we have something a little different. I have a 0 over here. So does it make that bigger or smaller? Well, when you have a decimal, I can add as many zeros as I want, and it means the same number. Adding zeros to the end does not make it any bigger or smaller. So this one is actually equal. I can add zeros forever if I want. It doesn't make it a different number. It's still the same number. before I do one more, if I have 12.437, it's the same thing as me saying 12.4370000. They are the same number. The zeros don't count at the end. Okay, one more. 63.4520 and 63.453. Okay, so let's check. 6 and 6 are the same, 3 and 3 are the same, 4 and 4 are the same, 5 and 5 are the same. Okay, so the first place are not the same is the 2 and the 3. That 0 does not matter. So which one's bigger? The second one. 3 is bigger than 2. So the first one is less than the second one. Now, just to add caution, be careful when they are negative. Everything I just did was at positive numbers. We have not even done a negative comparing, right? Now, hold on a second. Negative is sort of kind of backwards, right? Because for a negative, just to remind you, how am I gonna write it? Hold on. Here we go. Brain fog. Hold on. I want to write the right words. Okay. A negative number is larger if it's closer to 0. So like on a number line, -1 is bigger than -2. It's closer to 0. So negatives, you got to think like backwards. Okay, so let's try one. -0.039 and -0.0309. All right, so let's compare. They both have 0 whole numbers. There is no 0 whole numbers. So we have both have a 0 here. They both have a 3 here. And then this is where it changes. I have, oops, I don't want that color. I have a 9 and I have a 0. Okay, so which number is closer to 0? Is a 0 in a decimal form closer to 0? Or is a 9 in a decimal form closer to 0? Well, the 0 is closer to 0 in a decimal for negatives. So that is a bigger number. And if I think about it on a number line, this is sort of kind of be hard to sort of kind of think about, but 0.03 negative. If I think about negative 0.03, negative 0.0309 is here, and negative 0.039 is here. This is closer to 0. So it's almost backwards. It's almost like which one's a smaller number? That's your bigger one when it's negative. That makes sense? So if it's negative, you think backwards. When you compare them, the smaller number is closer to 0 than the bigger number. I even had to stop and think about that for a minute because it's backwards. Okay, so negative 0.0101 and negative 0.00109. Okay, they both have 0. They both have 0. This, oops, this is my first change. This one has a 1. This one has a 0. Okay, think backwards. I want the smaller one is closer to 0 so that 0 makes this the bigger one. So the first one is smaller than the second one. The fact that this is 1 and this is 0, and that's closer to 0 in a negative direction. So think backwards. If it's bigger when it's positive, that's our bigger one. But when it's negative, we want the smaller one. That's closer to 0. Negative 32.435, negative 32.443. All right, so let's compare. 3 and 3, 2 and 2, 4 and 4, and then I just saw it, 3 and 4. Okay. 3 is smaller than 4, right? Which means that's going to be my bigger one in a negative direction. So that means the first one is bigger than the second one. So just be extremely careful when it's negative. You have to think backwards. I'm going to leave that for about a minute, and then I'm going to do a new page. So make sure all of you are caught up. Anybody need more time? Okay, let me add a page. Okay, now with anything else, we can round. So we're going to talk about rounding decimals. Okay, so I sort of wrote out like things to look for. So first, you're going to locate the digit you are rounding to. You are rounding. And that's by the directions. Like it'll say round to nearest tenths, round to nearest hundredths. So look for that digit in your number, whatever the direction says. 2, you're going to look at the digit to the right, the one right after. So locate the one you're rounding to it by the directions. Look to the digit to the right. If that number to the right is 5 or more, you round up. If not, you don't round down, you just keep the number. Actually, let me just put don't round. I'll explain that more when we do a problem. Don't round, hold on. But I should probably say this, but drop all numbers after the digit that is being rounded. I gotta add it to the other one. Round up, same thing here, and drop, sorry, all digits after. Okay, so I sort of mess it up a little bit. Okay, if that number to the right is 5 or more, you round up and drop all digits after. If not, don't round, but drop all numbers after the digit that is being rounded. It's cat day again. I saw a white cat. I see a black cat. I love it. Where's dog day? I don't see dogs. We need dog day.
I don't think my German Shepherd would fit on my table. Sorry.
Sorry. So my dog, I tutor, I have a little business that I have, I tutor math at home. And I was tutoring math online with one of my students, and my dog, who's big, decided she wanted my attention. So she jumped up on the table in front of all of us. I like totally shocked me. I was like, what are you doing? It was hilarious because my student, like she's like in high school, was like, oh my gosh, your dog's standing right in front of you. It was sort of funny. So yeah, dogs can, if they want to. Very interesting. But yeah, we should have dog and bird day. I like that. I like seeing animals. They make us happy. Okay, so let's look at an example. Hey, we're going to round 482.7817 to the nearest thousandths. So in order to do this first, you have to know what thousandths is and be able to find a thousandths place, right? All right, so I'm going to write it down here underneath 482.7817. And I'm going to write under it what I would be thinking. Okay, so this is my tenths. This is my hundredths. This is my thousandths. Okay, so it's telling me to round this number to the nearest thousandths. So I look to the right and I ask myself, is that number 5 or above? And the answer is yes. So what I do is I take my 1 and I'm going to round up. So I'm going to add 1 to it and make it 2. But then I drop everything after it. So if I want to round it, it'd be 482.782. So I round this 1 up to a 2 because 7 was bigger than 5. And as soon as I write my 2, I'm done. Everything else goes away. I have a few to do, so I'll just put practice. We'll do a few and then I'll have you do 1 or 2 of them. Okay, so this will say directions round. Okay, 1. Round 536.4392 to the nearest tenths. Okay, so I go to my number. I look at my tenths. I like to underline it just so it stands out. This is my tenths. I look behind it. That 3 is not bigger than 5. It is less than 5, which means when I round now, it stays the same, except I drop everything after my 4. And this would be my rounded number, rounded to the nearest tenths. All right, so you find the position they want you to round, you look to the right. The number's 5 or more, you round up 1, but that's where you end, wherever you rounded. Anything after it gets dropped. If the number after it is less than 5, you keep the number exactly the same way it is, except you drop everything after what you're rounding to. Okay, let's round 106.345 0.26 to the nearest 10 thousandths. Okay, so we have to figure out where 10 thousandths is first, right? Okay, so this is my tenths, this is my hundredths, this is my thousandths, there's my 10 thousandths right there. So that's what I'm rounding right here. I look behind it, I see a 6, that is bigger than 5. So that 2 is going to become a 3. And my answer would be 106.3453, and it ends right with the 3.
So this is kind of like when we had the rounding and estimating at the beginning of the summer. Instead of commas, we're using decimals though.
Exactly. It's just like it. It's exactly like it. Yes, very good. Exactly like it. Just like rounding whole numbers. Exactly. Hey, you remember, that's good. Yay. It just looks different because it's decimals, but it's really the same thing. Okay, I'm gonna have you try one. Now, it's a negative number. It doesn't change rounding at all. Negative 0.032 to the nearest hundredths. Okay, so if you rounded to the nearest hundredths, tenths hundred, this is my hundredths. I look back, that's less than 5. So your answer should be negative 0.03. If you did that, you did a very good job. And I have one more for you. Round, whoops, I turned my page and it is not in front of me. Here it is. 3.14159265. Wow. To the nearest, let's see. Hundred thousands. To get that one a try. Okay, so let's see, tenths, tenths, hundreds, thousands, 10 thousandths, 100 thousandths. That's what we're doing. All right, if I look behind it, it's a 2. That's smaller, so it should be 3.14159. You did that. You did an awesome job. Do I see a dog? I see a dog. I finally see a dog. Hey, it's a dog. Okay, I love it. All right, now, this is a very special number. I'm going to introduce this number today, but we're going to use it pretty soon. But what I didn't tell you, and it goes on forever. Anybody know what that number is?
Miss Garrett, I was just thinking that when you had did that as a problem, I was thinking of pi.
That's what it is. That's what it is. It's pi. Woo-hoo-hoo. It is pi. Yes, it is. I just want to introduce it today because heck, we're rounding, right? But we're going to be doing something with pi pretty soon. So I wanted to remind you about pi. So pi has to do, well, what is pi? Anybody know what pi is? Do you know how pi is defined as? Probably not. They don't talk about it a lot. It's the, do you have to know this really? No, but I'm going to tell you anyway because it's cool. This is when I get to be geeky. It's the circumference of a circle divided by the diameter of a circle.
Someone said something about pi and they don't.
What's cool is though, it doesn't matter the size of the circle. It'll always divide and be equal to 3.14159.265. It goes on forever. It's also an irrational number because it goes on forever and never repeats. So because I can tie irrational numbers in, because it never ends, never means it goes on forever and never repeats. And that's all I'm going to say about it, just to sort of warm us up for something that's coming up later. One last thing about decimals before we actually start adding and subtracting them is very important when you do like a real world problem. With money. It's going to sound like common sense, but you're going to fall for it if you're not careful. When using money, remember to automatically, you don't have to be told, round to the nearest cent. Okay, so if you do a word problem, which will happen, and you get something like $139.465, that's not how we write money, right? Nope. So the answer, say you do all your computation and you get this number, right? That's not a money number. And you don't have to be told to do this. You have to do this. It'd be $139. And then you look at the 6. This is a 5. I rounded up to 47 cents. So when you talk about decimals and money, you always have to round your money to make sense. And I know it makes perfect sense, but you'd be surprised. Okay, that was 5-1. That was a lot. But that's a lot of the basic stuff all put together. Now we're going to start adding and subtracting decimals and looking at how to do that. I'll leave that up for a minute. And I got a little cute little problem for the practice. I'm looking ahead my notes while you catch up. Mm-hmm.
Hey, while you're leaving that up, Ms. Garrett, here's what I saw this morning in my office.
What'd you say? What is that? Is that a bear?
Yeah.
Wow. You saw this morning? Wow.
Yeah.
That's so cool. I want to see one, not up close, but like behind glass. That's so cool. Oh my gosh. I know they're around here. I just never seen one. I really don't want to see one in my front yard unless I'm like inside, but wow, that's so cool. Oh, I love that. Love that.
The only bear I know is this one.
Wow, that's so cool. One thing about moving here that I really love is all the I don't know, all the different kind of animals I've never seen before. I've never saw a pelican before till I moved here. Heron, never saw that till I moved here. It's just really cool. I never saw a dolphin in real life except for in a zoo. But I go to Navarre and I'm on a pier and there's dolphins jumping around. Like, it's really cool. It's cool. I love it. I'm a big turtle freak too. And I always see a lot